Over the decades, railways have only gotten safer. Occasionally we see an accident or two, but I think on average, it would be fair to say globally we've gotten safer. What are some underlying technologies that have made this possible?
Yeah, so it's interesting, and it's the story of railway safety from the first railway in 1825. I'm afraid has been learnt by crashes and people then improving the safety over time. So early crashes on the railways, for example, trains rolling back down hills and things, brought around automatic braking, and then people moved on as trains collided, and more signalling systems were brought together. So I guess the good thing about this is that the railways have had 200 years of experience of learning from mistakes, and those things have been improved over time. Today's railways are very, very safe. The underlying technology is safe. When things go wrong nowadays, they go wrong for two reasons generally. One is not just one thing going wrong, many things going wrong at once. Somebody doing something silly, a piece of kit not quite functioning the right way, somebody making an assumption about. So it's not just a single fault. Again, we refer to this when we talk about the Swiss cheese model. So Swiss cheese has holes in it. So if you imagine a layer of cheese with lots of holes in it, and you put lots of layers together, in order for an accident to happen, generally the holes all have to align, and then that's how you get an accident. So railway accidents happen when more than one thing goes wrong. And when you consider how many people travel every day around the world, it's they're an incredibly safe form of transportation. And as I say, the challenges that we have where things happen are generally caused by human error in some form and layers of that. And or natural disaster type things, so embankment slipping and those sorts of things. And both of those areas are things that over the years have become much better informed and understood. So certainly the things around human error are much better understood, about overworking people, around getting people to independently check work, around making sure that people have the right training and competencies to do their jobs, all of those sorts of things. So lots of work has been done around the world in that. And then in terms of things like landslips and things like that, there's lots of work going on in universities around the world, and those systems are being deployed, about early warning systems for these sorts of things and those sorts of things. So those are the things that are really impacting safety nowadays, but incredibly well. But fundamental to a railway engineer's point of view is thinking about safety. It's the kind of level of safety that we require in railways is much more than you'd ever think about in automotive or in other sectors, or even in healthcare and things. So safety is really at the heart of everything that we do in railway engineering.
And what are some new technologies as far as safety is concerned that are on the horizon, say in a university research lab, that you think will find the light of day in a few years?
Yeah. So and it's there's the big issues. Let's start with the signalling. It's the area that I work on. So the conventional signalling systems, the signalling systems that are used much over India, fundamental in their nature. They work on relays. So it's sort of 50, 60-year-old technology that's deployed at the moment. That and that's the same in much of the world. The digitalization of those sorts of systems is happening in India and is happening in other places in the world. And the benefit of the digitalization is that you remove lots of hard wires and cables that can be cut, and actually some accidents that have happened over the last 20 or 30 years have been where perhaps somebody's been working on site and not put the wire quite in the right place, and those sorts of things. You remove those sorts of potentials. Also, though, the other things that we have is obviously on a conventionally signal system is we have drivers looking at physical signals at the side of the railway. New control systems are in cab; they're autonomous, so you're not relying on the human in the loop quite so much, or at all. But then there's been improvements in braking. There's been improvements in understanding the forces in the steel wheel and the steel rail. We've had accidents in the UK where, for example, I was talking earlier about the rail and the metallurgy really being important. So we had an accident 25 years ago in the UK where we changed the rail, and we changed the rail to make it a more hardened rail, and we want it to be hardened because it was wearing away, and therefore you had to replace it. So it was costing money. The trouble was rails naturally crack. And as the rail used to wear, the cracks used to wear away, and it was all good. When you head harden the rail, the cracks don't wear away. The cracks just grow, and eventually, under a significant force, and there's a lot of forces there, the rail breaks. So much more understanding of the science of those sorts of things, and where we're really pushing the system to the extreme, understanding those issues. And again, good systems thinking, from an asset engineer's point of view, head hardening that rail is really, really good because it saves you money, saves you doing maintenance. Not great from a metallurgy and cracking and a forces point of view. So again, having that good understanding is key.